Hello, ladies and gentlemen. Welcome to Math 30-1, Chapter 7, Lesson 6, Double Angle Identities. A continuation of the sum and difference identities we did yesterday. Now, first thing, prove that sine of 2x is sine 2x cos x. Well, that's easy enough. This is sine of x plus x, or a plus b. That's sine a cos a b plus cos a sine b. Be sine of x cos of x plus sine of x cos of x, or 2 sine x cos x. So that's a double angle identities we're dealing with down here. Okay? Now, that was easy. Next one. Prove cos of 2x equals cos squared x minus sine squared of x. Well, that itself is fairly easy. This is cos of x plus x. That is cos of x minus sine of x, or cos squared of x minus sine squared of x. Now, that's fairly straightforward, but something I want to point out here. Where have we seen cos squared and sine squared before? Well, we have seen cos squared before as 1 minus sine squared of x. So we can write it like that. Move it over. Now that becomes 1 minus 2 sine squared of x. Okay? And where have we seen sine squared before? Well, sorry. Forgive me. So I can go cos squared of x. Instead of writing minus sine squared, I can write that as minus 1 minus cos squared of x. That becomes, 2 cos squared of x minus 1. So for cos of 2x, or 2a, there's 3 different formulas. That's going to be a tricky one, deciding when to use which formula. But with practice, we'll figure that one out. Now, let's start off fairly straightforward. Simplify 4 minus 8 sine squared of x. Well, we have 2 terms, a binomial. Notice we can factor out a 4 from both terms. We're down to 1 minus 2 sine squared of x. Now, where have we seen 1 minus 2 sine squared? Well, that's cos of 2x. Just that right up here, 1 minus 2 sine squared. So we can make this 4 times cos of 2x. Right, now, I want to point out something important. This is not equal to cos of 8x. Okay, it's not. If you think about it for a minute, cosine goes up and down, fluctuates. So it doesn't automatically become 8 times bigger. Now, some slightly harder questions. Which is equivalent to 2 cos of a cosecant of 2a? Well, 2 cos of angle A is fine, but cosecant is 1 over the sine, in this case 2a. Now, there's only one value for sine of 2a. That is 2 sine of a cos of a. And note, we should write that as one nicer term. 2 cos of a over 2 sine of a cos a. When you do it like that, cos of a cancels, 2 cancels, down to 1 over sine of a, which simplifies to a cosecant. Now 1 over sine of a is the correct answer, not one of the answers we have, but that is cosecant of a. which is option C. All right. Now, one more in this video. Two more maybe. So, looking at this one here, which is equivalent to cos 2a minus 1 divided by 2. Now, here, cos 2 theta, we've got three options. We can make that cos squared minus sine squared, 2 cos squared of a minus 1, or 1 minus 2 sine squared. They'll all work. I don't care, well, I do care which one you use, because if we go replace this with 1 minus sine squared of theta, notice we have a plus 1 divided by 2. Now, sorry, minus 1, forgive me. Now, why did I choose the 1 minus sine squared? Well, what's 1 minus 1? It cancels out. Oh, sorry, 1 minus, oh, sorry, I can hear you screaming at me. That's 1 minus 2 sine squared. Sorry, guys. Forgive me. Let me try that again. Cos of 2 theta is 1 minus 2 sine squared of theta. Now don't forget the minus 1 at the end and divide by 2. So the 1 minus 1 cancels out. And if I wrote it out properly, minus 2 sine squared of theta, whole thing divided by 2. The 2's cancel out, and we're down to minus sine squared of theta. Okay. That was embarrassing. All right, so let's do one more. Now let's do a couple more in this video. Anyway, 1 plus tan of x divided by 1 over cotangent x equals 1 minus cos of 2x divided by sine 2x. Now, here, there's a lot of different ways to do it. Excuse me. So, now, this is a particularly nasty one to end the video off with, but let's work on it. So we want left side equals right side. And I think we're going to have to simplify both sides. 1 plus tan. Now tan is, double checking because I'm old, sine over cos. Sorry, sine of x, cos of x. Now cotangent is cos of x over sine of x. Now, 1 minus, I'm going to skip the cos of 2x for a moment. Sine of 2x is easy. That's 2 sine of x cos of x. Now, which version of cos 2x do I want to use? Well, it's 1 minus. So do I have one of them with something plus 1? Right here. 1 minus 2 sine squared. Now, the reason I'm choosing that is 1 minus 1 is 0. That becomes 2 sine squared of x over 2 sine x cos x. 2, one of the sines, one of the sines. This becomes sine of x over cos of x, which is tan of x. So I simplified the right side quite a bit. What about the left side? Well, once again, all right, this is 1 over 1. I need common denominators. This will be cos of x divided by cos of x. This will be sine of x over sine of x. So the left side becomes there's my left side. It's cos of x, numerator is cos of x plus sine of x divided by cos of x. Whole thing, my denominator is sine of x plus cos of x divided by sine x. Now, So writing it like that with as a division statement. Now I will say, most of you guys are getting this, so you realize you can probably skip a step or two here. You could go directly to this. Cos x, sin x, cos x, same thing. This becomes sine of x over cos of x, which is tan of x. And left side equals right side, I'm happy. Because tan of x equals tan of x. Now I'm going to pause the recording here because it's getting kind of long. But you see this with practice, you can get these. And yes, there's more than one way to do it. If you see a shorter, quicker way, show me, and I'll gladly change the notes up.